Good morning, everyone. Welcome to online CRT classes. Today we are going to discuss number system part 8 and very important concept in number system. And just a recap of the number system, we already discussed the types of numbers, factors of the numbers, power cycle, divisibility rule, product of the cycle. And from basics and also we discuss everything. And now the last concept here, that very important concept, that is remainder theorem. Remainder theorem. Okay, remainder cycle or remainder theorem. So very important concept. So you must listen carefully and practice most of it. So because it's very important concept in all the number system. Okay, so remainder theorem. Now we'll start from the basic onwards. Basics onwards. So what is a remainder? What is the everything? From basics onwards we'll discuss. Right. Okay, first of all, right? Take an example of this. First of all, suppose if they are given 71 divided by 13. Okay, how we are going to divide this? So 13, 71, and which is closest multiple of 71. I mean, number will get closest number which multiple 13. 13 fives 65, right? So remaining what will get 71 minus 65, it's nothing but 6. So here I think everyone knows this is nothing but divisor, right? And this is dividend. Divisor, and this is dividend. And this is quotient, right? So I think everyone knows this, and this is our concept. It's nothing called but remainder, right? So this is divisor, dividend, and quotient, and this is remainder. I think it's a basic concept. Every student will know this, right? Now, and the number dividend is nothing but divisor into quotient plus remainder, right? So dividend equal to divisor product of quotient plus remainder, right? So this is what the basic thing. First of all, okay, we'll see something, some examples of it. Okay, I given 17 by 13. What's the remainder? Just now we'll find, that is 6, right? 6. See, no, one more. So 41 by 13. What's the remainder? So 13 was 13, 3 is 39. So it is 39. It's nothing but 2. 2 is the remainder here, and 6 is the remainder here, right? So here 71 is biggest number compared to 13. I'm getting remainder 6. And even that 41 also is greater number compared to 13. I'm getting 2 is the remainder, right? And if I divide 7 divided by 13, 7 divided by 13, what is that? Remainder 7 itself. Then how we are getting the 7 itself? See, 7 13 into 0 is 0, and 0 will get 7. So whenever number is less than this number, numerator numerator number is less than the denominator, then remainder will be numerator itself. Even that 11 by 13, right? So whenever if you are dividing a smallest number, that remainder will be same number will be remainder. Even 11 itself the remainder, right? So this is the first case. Whenever if you are dividing a biggest number with small number, so then we'll get the remainder. The closest nearby value will take, and then where what is subtracting that one, what is the extra number is there, that is nothing but remainder, right? That is a remainder, right? And now if I take 286, if I take the 286 divided by 13, right? 13. Now, so it will take 13 twos, 26 and 26, 22. So we can divide this 286 number exactly multiple by 22. That is, remainder will be 0. So first of all, three concepts. What is that? Whenever if you dividing with big number, then we'll get the remainder. Okay, that may be whatever the remainder. If you are dividing a small number compared to divider, then we'll get the same number as a remainder, right? And another one, if any multiple of the number, suppose divider, denominator multiple, whatever the multiple, that is here 13 into 22, it's multiple, 7, 91. So 13 by 91 by 13, we'll get 7, that is 0. It just, first thing, if it is a big, we'll get the remainder, and it's small, the small number itself is a remainder. If any multiple of that divisor, if you are dividing, then we'll get the 0. That is exactly you can divide. It is exactly divisible by this number. That time we'll get the remainder is nothing but 0. 0 is the remainder, right? Now I can give a small statement here. So just observe that even at 41 by 13 by 60 by 13 or 97 by 13, whatever the number, you just divide. So this one will be nothing but 2, this one will be nothing but 8, even this one will be 6. So observe this, the remainder always is less than the divisor, right? The less than the divisor. Remainder always less than the divisor. So this is very important. I think everyone knows this. It's a basic concept. I'm starting with a basic, right? So even we'll get the remainder up to 12. Okay, that means if 13 is n, then the remainder will get n minus 1. Up to n minus 1 will get the remainder. If 13 is there, then we can divide with 1, right? So like this. Then now, for example, now I'll say when a number is divided by n, the remainder will be less than n. Right? It's very important. So remainder will get 1, 2, 3, and so on, n minus 1, up to n minus 1. Right? So when a number divided by n, the remainder will be less than n, right? Up to this, is it clear? Right? Now we'll go for the negative remainder concept. What is a negative remainder? Don't think that remainder will get the remainder in negative. Oh, no, right? So generally we'll get the remainder, right? In positive only, right? But I'm introducing a negative remainder. Negative remainder. Now, generally, suppose see, generally what we'll do, suppose I took 25 by 7. 25 by 7. So generally we'll consider the less number, nearby less number of this, right? So 7 into 3 will get 21. So remainder is nothing but 4, right? Remainder is 4. So how we are going to get this? How I got this remainder? Remainder 4 is nothing but we are finding out the nearby value of 25, right? Nearby less value of 25. It's 7 3 are 21. So remainder is 4. Now, what is the negative remainder? Negative remainder. Just find nearby biggest value, a greater value, nearby greater value of 25. The multiple of 7 that will be greater than 25. That is nearby. So 7 fours. What is 7 fours? 28, right? Now, what is the difference here? 25 and 23? 28, it is 3. It is nothing but minus 3 minus remainder minus negative remainder. Negative remainder is minus 3, right? Suppose 10 by 19, right? So here, so what's the nearby value here? Multiple of 6. Sorry, 5 only, right? So 6 is greater than 4. Okay, now see. 19 fives. 19 fives is nothing but 95. 95 minus it is remainder is 15. Remainder is 15. And what is the nearby biggest, greater value of this 1110? 196, 114. It is nothing but minus 4. Okay, and no, 98 by 23. So just 4, right? See 4. Yeah, it's nothing but 6 is remainder. And then yeah, 6 and 24 near just next number of that one 500 550 150, right? 115 means what's the remainder? 17, right? Yeah, 17 is negative remainder. See, observe this negative remainder. What is I'm taking? In generally, everyone take the remainder. It's a nearby value is less than value. 25 less than value will get 21. That is the remainder is 4. And 25 just biggest value is nothing but 28. That is will get minus 3. Just observe this positive remainder and the negative remainder. will get the same number. See, the number minus, this number and this number will get 4. 7 minus 3 will get 4. Or just add 4 and 3 will get 7. 15 plus 4, 19. 19 minus 4, 15. 23, 6, 17, 23. 23 minus 17, 6. So everywhere, the negative remainder and the positive remainder will give the divisor, right? Clear? So this is nothing but the both value addition of this, you will get divisor, right? So negative remainder is nothing but, generally if you are taking the positive value remainder for, the nearby value is less value. But if you are taking another value, that means just if for a small example, simple example, 12 is there, right? That is nothing but 5, right? So 5 ones, 5 twos, 10. The remainder will be 2. But what's the, that is 10 is nothing but less than the value. 10 is just before. What is that? 5 into 2, right? 5 into 2 is nothing but 10. So just 5 into 3, do it. If you are getting remainder here, then 5 into 3 also will get the remainder, that is 15 minus 12 is nothing but minus 3. See, this 3 and 2 is nothing but 5. Is it clear? Right? No. If, so this is negative remainder. Now, we'll see some more examples here. See. Suppose minus 98 by 13. What's this remainder here? 13 sevens, 91. 91, that means 7. So just leave about this minus value. Minus 98 is here. Then it is minus 7. Minus 7 is a remainder. At the same time, if the next number, what's the next number? 104, it's nothing but 6. Right? So 6. This is positive remainder. Here, if you just add these two, 7 and 6, we'll get 13, right? We'll get 13. No. The same way. And sometimes we'll do, this is also, if you're dividing negative numbers also, we'll get the same, okay? So then why this is 6, I'm taking minus of minus, is the number 6, okay? Now, see, if I given 119 by 21, okay? Suppose, and if to find this remainder, I'm just simplifying this. 7 ones, 7 threes, 7 sevens, right? So now 7 by 3 I got. Now what's the remainder? 7 3 7 17s. What's the remainder? 3 5s. 2 is the remainder, right? So but it is a wrong. So whenever if you are simplifying, and then we'll get this remainder will be less than the actual remainder. What's the actual remainder? So which number if you are using to simplify this, we have to multiply that number. We are getting 2, right? So 2 into 7 is nothing but 14. 14 is a correct remainder actually. It is correct remainder actually. Okay? Then no. In the same way. So 95 by 25, right? So if I simplify this, so with 5 5 5s and 5 19s, right? So 19 by 5, 19 by 5. What is that? Remainder is 4, but this remainder is not going to be original remainder, actual remainder. This 4 is after we are getting the simplification. So which number of your simplification with 5? So 4 into 5 will get 20. This is actually actual remainder, right? 20 is the actual remainder, right? Okay, these are the everything is basic one, basics. Now, suppose 130 divided by 17, and 130 divided by 17 is nothing but we'll get remainder is 11, right? Suppose we can write this 130 like this, 90 plus 40, 90 plus 40 by 17, right? So we can find like this also. 90 plus 40 is 130 and divided by 17. Now just see. So 17 and remainder is 5 here. 17 5 is 85 and 5 is the remainder and 40. And here it is a 40. Then it's nothing but 6, right? So 30, 17 3 is 54. 54 that means 6. So remainder will be 5 plus 6 is also 11, right? It's also 11. Then, and suppose if I take the one is positive, another one is negative remainder. We'll check. Now 90 plus 40. Even if you're dividing the number, I mean, even that adding the number or multiplying the number, we'll get the remainder will be same. So 90 plus 40 divided by 11. So see here, what is the positive remainder? 5, right? So take this negative remainder. What is that? I'm sorry, 34, right? So it is 3 is 20, 2 is 34. Yeah, 2 is 34. And if it is a negative remainder, 51, 17 3 is 51. What's the negative remainder? Minus 11. No, minus 11. Now we just add this. No, just add this. What is it? Minus 6. Minus 6 we're getting. But it's a different? No. Minus 6 is a negative remainder. If you want to original remainder, just 17 minus 6 will get actual remainder 11. Even if you are dividing with the directly number, even that number I can write a 90 plus 40 or 90 plus 40 with a negative remainder, everything will get the same remainder only. Every time it will give the same remainder only, 11, even 11. Here also 11, like that. Okay. Now, let's see some more examples. That 79 into 103. Now, result here, just divided by 11. Right? Now, check this 79, 77, 7, 77. 2 is a remainder. Then here, 99, 9. It's a 4 is a remainder. So, into, here into, right? So 4 into 2 is nothing but remainder is 8. Even this multiplication also, you can find the remainder. Is it clear? When that 2 into 4 also is nothing but 8. Okay? And even that negative remainder also, 79 into 103. 103 divided by 11. Just, what's the next number? 88. 88 minus 79 is 9 minus 9, and it is nothing but 4. What's it? 9 into 4. 9 into 4 is nothing but 36 by 11. Then 36 by 11 is nothing but 36 you can take 36. Now it's 11 is 3, right? So it is nothing but minus 3. So 11 minus 3 you get 8. Again remainder. So you have to observe that the remainder will be same for the multiplication, addition, and the negative and positive remainder. Everything will finally get, we have to write positive remainder only, not take the negative remainder. So the negative remainder is only for make calculation simple, right? So basis, so remainder will be not going to be changed for any time. Okay, is it clear? No, I'm going to clear this first of all. Now, very important point here in remainder. What's that? Fermat's theorem. Fermat's theorem. Yeah. What's the Fermat's theorem? What's the statement of the Fermat's theorem? Because this is what we are going to use is in remainder theorem, the Fermat's theorem. So whatever if you are using that Fermat's theorem, so if you are seeing the question, then immediately you have to identify so which method we are going to apply to get the remainder. Now, what is the Fermat's theorem? It's nothing but a power a power a power p minus 1 p minus 1 by p p. Here, if this is if this is if this is our if this type of number if you got, always remainder will be 1. So take this, remainder will be 1. But here the condition is p is a prime number, any prime number, a and p should be co-primes. But the co-prime we already discussed, right? But the co-prime, so when we'll get HCF is 1. That means there is no common factor in between the two numbers, that is nothing but except one, that is nothing but co-primes. So here a and p should be the co-primes, then the remainder will be 1. Now we'll take some examples of this, right? Fermat's theorem. Okay, note it down first of all. Then Fermat's theorem. And this one, note it down now. I just clear this one actually, so you have to note it down this one. Okay, remainder will be 1. Okay, so note it down first this. Then no. For example, we'll take one example. 40 by 29 by 28. So we got this format. Then you can directly, so without doing anything, first by seeing itself, you have to understand. So this is comes under the Fermat's theorem. What is the Fermat's theorem? 29. It is a prime number, and 40, 29. There is no any other factors in between 40 and 29. That means these two are co-primes. So co-primes, and 28. 28 is nothing but 29 minus 1, right? So in the same format, right? A power p minus 1 by p, right? So directly you can say remainder will be 1. Then remainder will be 1. And some more examples will check. So 38 by 103 over 102, right? So 103 prime number, then the co-primes 102. It is remainder will be 1. So you have 64 power 30 by 31. See this and this 1. See. And 87 by 83 power 82. 1. So by using the Fermat's theorem, so everywhere we're getting, just observe this power and this denominator, power and denominator, power and denominator. And if these two are co-primes, these two are co-primes, these two are co-primes, remainder will be 1. No need to do anything, right? Now, we'll check one example. The remainder when 3 power 21 by 5 by 5. So now is divided by 5 is, what is the remainder? What is the remainder when 3 power 21 is divided by 5, right? See, now what they given right here. So 3 power 21 by 5. So don't expect directly they will give the values in exams. So you have to find out that is it any possible to find the remainder, find that the Fermat's theorem in this. So if I got this, so I can do this is 2 R prime numbers first thing, right? So that means co-primes. And but here it is 21 is there, 21 is there. Is it not clear? So what we have to here, it is nothing but 5 minus 4 I want, right? Is it clear? No. See. So I can write this. 5 minus 1. P minus 1, right? P minus 1. What's that? 5 minus 1, 4. So I can write this 4 multiple. Yes, of course. 3 power 4 into 5. Into 5. Or power 5, right? Into 3. So now just see 3 power 20 into 3 power 1, 21 by 5. Now see this one. This is format of Fermat's theorem. So 3 power 4 into 5 divided by 5. Co-primes and 5. So this remainder will be 1 and into, and we know this, and if it's a less value of the divided, the remainder will be less value only 3. So remainder will be 3. Right? So now I'll give some of examples here. I'll give some of the examples. Just do it that one. Sure. Find the reminders. Find the reminder for 72 by 29 by 85. Now check this. Is it any possible to make this question in Fermat's theorem? So 29. What we have? 29 is a prime number. Okay. And 72, 29 is a 72 and 29 is co-primes only. But what I have to do here? So here we need to make 29, right? 29. Now, how we can write this? Make it. Try to solve this and give the answer. do it. See here. So 72, I can write this in 28. Here I have to, if I have 28 here, then the remainder will be 1, right? So I can write this 72 power 28. 28. What's the nearby value of 28? 28, it's 3, right? So power 3. So 28 into 3 is nothing but 86, right? Into 7 by 29. By 29. I can write like this. 72 power 85. I can write like this, right? 72 power 28 power 3 into 7. Into 7. So this is nothing but 84. This is nothing but 84 into 7. It's 85, right? Now, I can write this. The remainder is 1. So 1 power 3. Remainder is 1 and this 1 power 3. It's nothing but 1 into 7. What's in the word? Limit 72, right? So it's the limit 72. 72. So 72. What's the remainder here? What's the remainder here? 72. 29 divided by 72. 72 it's the limit. 14, huh? Yes, 14. 14 into 1. 14 is the remainder. Right? The same way, I'll give one more question. So 4 power 2007 by 17, if they're given like this, then how we are going to make this in the power of 16? So these are prime and these are co-primes, and we can write if in the 16 form. If it is, then the remainder will be 1, right? But so 16 power 16 into 125. 125. 125. Just divide this one. Okay. And into 4 power 7, right? So here just do it. 2007 by 16. It is nothing but 125. 125 into 4 by 7. So this will be 1, right? This will be 1. Now, this remainder 1, right? Into 4 power 7 is there. I cannot do this 4 power 7. I can write 4 square, right? 4 7 16 into 4 square 16 and 2 4 power square 16. I can write this 4 power 7 into like just a 4 square into 4 square into 4 square, right? So 4 into 8. To 4. 6, right? So add 6 plus 1. So I can write like this. No, 17. So this remainder is 17, sorry, 1. And this is nothing but minus 1. This is nothing but minus 1. This is nothing but minus 1, 17. Okay. And this is nothing but 4. So minus into, right? So minus 4. So, but negative will be not in remainder in negatives, right? So just 17 minus 4 is nothing but 13. 13 is actual remainder. Okay, done. So we'll continue this second remainder theorem also in next class. Okay, thanks for watching. Bye bye.